So in this example, I'm going to use an analog input card to simulate a temperature reading. So the card I'm going to use is the 750/469/000-003. That's an analog reading of a negative 120 millivolts to 120 millivolts. Ideally, you want to use the 750/469/003-000, which automatically gives you a K value. But for this exercise, just use what I have. So what I'm going to do is I'm just going to set the communications in IO check to the service cable, and just to show you the changing value. So if we go to monitor mode in IO check, it brings up the current cards. Go to right click and process data, and you can see that there's a reading of negative 0.42 millivolts, and that will change as I touch it. So I've got a thermocouple connected to the left hand side of the card. Okay, so we'll stop that now, and now let's create our project. So again, we're going to use the 750/880. Okay, and we'll use CFC as our programming language. Now for communication parameters, I'm using the serial cable just for demonstration purposes. You are better off to use the Ethernet cable. To show you how to change the COM port is actually a little bit different, so I'll do it from scratch. So just click New, Serial, OK, and see how it says COM port 1. I'm actually using COM port 5, and you determine that from Ethernet settings. How to change it, you just double click it until it goes to 5, and you can also cycle that through. I think it goes up to about 32 COM port, and then it goes back to 1. So we'll click OK. Now we'll have to add the cards again, so let's go back to the Resources tab, PLC Configuration, open up KBus, right click, click Edit. Now let's add the cards. So I've got my 400 input, got the 501, and I've got the 469. So this is the one I have, so you can see it's plus or minus 120 millivolts. It's just the card I had on me. So now I'll name the input, so it comes out as an integer, so I'll denote that as I temp_1, and that's where the thermocouple is connected in, the first address. I'll also name my input output again, and then I'll click OK. Alright, so now we'll start writing the program. So go back to the programming screen, PLC_PRG. Now what I'm going to do is so the input, I'm going to put itemp_1. That'll be our input, and I'm just going to maybe scale this. I might just add a value just to get a positive reading of maybe 40, and then this will give me temp actual, and this will be a real value. So all I'm doing is just scaling the value that I'm receiving. To accurately convert the millivolt signal, it is a little bit more complicated, but for now we'll just add a number just to make it a bit easier. Now, because I is an integer, the temperature value that we get from the analog card, we actually need to convert that to a real number because integers don't have decimal points. So to get a better reading, we need to do this. So to convert it, it's int_2_real, and this will convert the integer value to a real value. Okay. There's another way to do it. You can also just add 40.0 and that will round it to one decimal place, but it's better just to convert the actual variable. So now if we log into our controller, click yes, online run, So we get a negative 64 value reading, which is meant to symbolize the room temperature. We've added 40, it's negative 24 degrees. So if I touch the thermocouple, it will go up. But yeah, it's not 100% accurate, but we're just using this to simulate an analog value. Okay, so now what we actually can do now is add in alarms and things. So for instance, if we say if the temperature is greater than 30 degrees, then turn on a cooling system. If it's less than 0 degrees, then turn on the heating system, something like that. So how we do that is we'll add in the greater than operator. We'll now put this here. So it has to go in after the and add. So if it's greater than, let's say, 30 degrees, then we can turn on the cooling. So for the cooling, maybe we can just do X output 1. So you link the output to an air conditioner or something like that. And if it's less than, zero, then we'll turn on the heating. Oh, the heating can be X output 2. I actually haven't defined that yet. Let's go back and define it. So we'll go back to the program, we'll go online login and online run, and now you can see that we've got a negative temperature of negative 30 degrees, so it's less than 0, so the heating is on at the moment. What we also can do is we can also simulate a wire break. So a wire break basically is a faulty wiring. If the wire's been cut, for instance, there is an automatic error value that comes up. So I'm just going to disconnect one of the wires in the thermocouple. So I'm pulling it out now, and you can see that the temperature reading goes to 32,767. So that's the error value that you get when there is a wire break. We can actually use this value in our programming. So if there is a wire break, we can get it to send us a notification or get it to stop logging the temperature, for instance, because you don't want this outrageous value to be in your analysis starter. So we'll do that now. So we'll just log out, and now what we'll do is we'll write just a little bit more itemp1. So when that equals, so I'm putting equals now, when that equals to 32767, we'll get it to trigger a variable. So we'll call this X wire break. So when the temperature equals this value, specific value, then there will be a wire break. As you can see that there is a disadvantage. So if there is a wire break, because the value is so high, it's going to be above 30 degrees and the air conditioner is going to come on, for instance. So what we actually want is, if there is a wire break, to not turn on the air conditioner. So we can do that by adding in another operator. So maybe we'll put in an AND operator, and then we'll connect that, and then we'll connect this, right? And now we will negate this value. So at the moment, if the temperature is greater than 30 degrees, and if there is no wire break, because I've negated that value, then the air conditioner will come on. But if there is a wire break, this will be true, and then this will be false because of the negation, and then the AND operator needs both to be true to turn on the output. Okay, so that's one way to do it. There is also another way. You can use the move function. So the move function we can put up here. Actually, we'll just run this first, so you can see. Yep. So uploading the program now. Online run. And here you can see that it's above 30 degrees, but because there is a wire break, the output one isn't turning on. So you're not going to get the air conditioner to keep cooling because someone's cut the wire. Okay. So there is another way to do this. You can add in the move function as well. So I'll move that here. So what the move function does is that if there is a wire break, it will pause the actual temperature. So what you do is you right click on the move block, click the enable option. Now we reconnect this together. And then now what we'll do is we'll put in the variable X wire break. Just move this across so it's a little bit neater. And now we'll negate this. So everything will go well. If the wire break is false, then this will be true, and then it will be fine. But then when the wire break is true, this will be false, and it'll just pause the temperature. So I'm going to reconnect the wire back into the slot. Just give me one moment. So I've put the wire back in. I'm going to log into the program now. Online run. So now we've got this temperature value that is recording at the moment. So negative 30 degrees. I'm going to now turn on the wire break. Now you can see that this didn't work. The temperature is actually meant to freeze at negative 30 degrees. It's not meant to go to 32,000. Now the reason why it didn't work is because I haven't ordered it to according to data flow yet, because I've just added this in. So after you add something in, you have to order everything to data flow. And lastly, we also need this move function block to be at the start of the process. So we have to right click on that and go to order and order at the start. And you can see that the order number has changed to 0. So this is the function block that will start first. Now we'll go online login. Yes, and I've also put in the thermocouple wire back in. And I'll click yes. And then online run. So we'll have a negative value, negative 28. I'm going to create a wire break now. And so I've created a wire break, and you can see that the temperature value froze at the last recorded value. So the 32,000 value doesn't come up there.